All right, here we go. So let's see. Data from patients admitted to an intensive care unit. There's 200 observations. I am concerned about their status, and that would be whether the patient lived or died. Lived is a 0, died is a 1. Got to get those zeros and ones right. Otherwise, that's not good. And the other thing I want to look at is, was an infection involved, yes or no? 0, no, 1 is yes. Okay, that makes sense. 0 is no, 1 is yes. But in this case, like the status is kind of weird. 0 is a lived and 1 is a died. All right. So what I want to do is I want to look at was it significant if they had an infection on living or dying? Okay. So first I'm going to write that down, and then we'll try to get that out of the data. So my question, is there a significance difference in the proportion of ICU patients who died whether they had an infection or not? So the first thing we'll do is we'll run a confidence interval on this and see what that looks like. And then we'll do the hypothesis test. So let's define some parameters. We're going to have a P1, and let's say the P1 is that they had an infection. So portion of ICU patients patients with an infection died. And then we'll do a P2 would be the patients who didn't have an infection and died. Portion ICU patients with no infection who died. And then we're looking at a difference in proportions. So we want to know what is the range of values for P1 minus P2. Right, the percentage of people who died that had an infection versus the percentage of people who died who didn't have an infection. And to do that, we have sample data. So we're going to have our P1, that'll be X1 over N1. And these are the infection who died, infection, and, excuse me, died. Divided by the number of people who had an infection. So we're going to get that out of there, the stat key table. And then P2, X2, N2. Those would be the people that did not have an infection. And they died, divided by the number of people with no infection. And sometimes somebody's already done the summary of all of that. Other times we have to grab the raw data and get the summary. Last example, we have the summary statistics. This time we have the raw data. So I'm going to show you how to pull summary statistics like this out of the raw data. Many ways to do it. So I'm going to go over to that spreadsheet. Okay, so ICU admissions. And I already copied over the status column. So status was whether they lived or died, 0 being lived. And then infection, whether they had an infection or not, and 1 is they had an infection. And I brought that into a new tab. And then down here, I just had to do a calculation called a count if. So count stuff in column A if column A was a 0, which means, let's see, a 0 in column A means they lived, right? And I am in the lived column here. So altogether in the lived column, there were 160 ICU patients out of 200 who lived. Not bad, not great. 40 out of 200 died. And then of the ones who lived, 100 of them had an infection and 60 did not have an infection. And then similar, for the died column, there were 40 people that died. 16 of those 40 had no infection and 24 had an infection. Altogether, 116 of the 200 had no infection and 84 had an infection. So to do that, I did a bunch of count if S statements to make that happen. This is also called a contingency table or a pivot table. Anyone played with pivot tables in Excel or Google before?
Yep.
You have? Okay. So I'm gonna see how Google does a pivot table automatically, because that was not too much work, but I had to look up how to do that. So I should just be able to highlight the data. So I'm gonna go to the bottom and then go up and then say, hey, let's insert a pivot table. Okay, and I want to put it in the existing sheet, and I'm going to stick it right there at the top. Okay, great. All right, what do we want to do a pivot table of? Let's back up. Usually I go by row, but it doesn't really matter, I don't think. So I'm going to add a row. So my rows represent what in my table below? So I'm going to try to reproduce that table. Infection, right? The rows are about total number with an infection, total number without. So I guess I should select row infection. Okay. And then it's suggesting that I want to count the status for each status by infected. Sounds right. That button. Oh, interesting. How is that similar and different from the table I did down below? It's transposed, isn't it? The rows and columns are flipped. Notice the totals. The row totals are 160 and 40 versus mine is the columns are 160 and 40. All right, so let's see, either my table is wrong or their table is not what I expected. Let's just double check. If I count up the total number of people with an infection, so if I can just click on column B and let's see, notice the sum down here on the bottom right, it says there's 84, it's basically trying to add everything there and words don't count. So it's saying this column adds up to 84. So this 84 right here is the number of people with an infection. And then if I click on the status column here, it's counting 40 ones, and a 1 means they died. So this right here is died. Okay, so the pivot table didn't give me quite what I expected. I was expected a transposed version of what it gave me. I thought it was going to, when I chose the rows to be status, or no. Oh, didn't I choose the rows to be infected? Did I click that wrong? Maybe I clicked the wrong button. Ooh. Oh, it plugged all that shit in after. Okay, I'm going to start over. But it's not quite right. You agree, it's transposed compared to what I have. So be careful when you make a pivot table. It might not put it in exactly how you would expect. So let's delete that and start over just to make sure I didn't push the wrong button. All right, so again, highlight your data. Let's go from the bottom up. Insert your pivot table. I said put it on the existing sheet here. Okay. Create rows infection. Okay, it definitely says rows infection. And then, oh, it's not showing me other stuff. Maybe I have to turn it off and on again. There we go. Yeah, it switched the rows to status after I click that button. Okay, so pay attention to the details. So this isn't quite the table I was expecting. Instead, this right here, the 160 is my lived. This is my died row. And then down here, the 116 is my no infection. And these are my infection. So cool thing, you can get summary statistics from a bunch of raw data with a pivot table. You just got to make sure you pay attention to which number's which column and which row is which. All right, so we have everything we need to do this. I'm going to let's grab Google's version of it and see if we can come up with this. So add to current page. All right. So all the information for X1, X2, N1, and N2 is in this table. So I'm going to pause the video for a minute, and I'm going to have you guys try and come up with the standard error and then the margin of error for a 95% confidence interval based on the formulas we used in that previous example. And again, those formulas are right there. There's the standard error calculation. So using that formula for standard error, the numbers in this table come up with a standard error and a margin of error. And then we'll get the confidence interval. Go. Resume. Okay, so we're back at it. So again, looking at the table, the proportion who died that were infected, that would be the second column here. And I got 24 out of 84 for that one. And then out of the non-infection, people that did not have an infection in the ICU, 16 out of 116 died from that column. This is the standard error formula we use. We only pool the values if we're doing a hypothesis test, which we're not doing yet, so we don't need to do that. And for 95% confidence interval, my z-score is going to be about 1.96. And for the margin of error, right, we're going to multiply those two together. Now, I'm not going to use a calculator for this. I'm going to use a spreadsheet, which is a lot of calculators all at once. And so into my spreadsheet, I plugged in my confidence level, my ratio, numerator, denominator for infection, numerator, denominator for not, and then it calculates the proportions. So about 28, 29% of the people with an infection died, whereas only about 13, 14% of the people without an infection died. That seems significant. And then I got a standard error of 0.0588-ish, which with a z-score with a whole bunch of decimal places, that gives me a margin of error of about 0.1152. Are you all getting answers in the ballpark of that? Yeah, and again, it's going to be a little different if you use like the rounded z-score 1.96. And sometimes the homework is going to be like, oh, you're 1 decimal off. Just message me if that happens and say, here's how I did it, and I can check it out. And then here's my lower and upper bounds on the margin of error. The difference is somewhere between 3% and 26% in the population is what we're guessing at here. All right, so let me grab that. The stuff I need to know here to make a sketch of this is I need to know the difference in proportions, margin of error, lower and upper. I think I probably need a new page for this. All right, so I'm going to sketch out what the calculator told me here. The center of the distribution is that difference in proportions up here. So the difference in proportion of people who died with an infection versus without, and it's important that we're taking the infection death rate minus the no infection death rate. That order matters. I'm getting a positive difference that way. If you get those backwards, you get a negative difference. That happens sometimes, right? It's the order we picked, but the interpretation, you got to know which direction it went. So again, middle of my distribution is about 14.7, 14.8. I'm just going to go 1478. Let's go to 4 decimal places here. Lower estimate based on these sample sizes is 0.0326, and the upper estimate is 0.2630. So we believe the difference in the rate that people died, infection minus no infection, is somewhere between 3% and 26%. We're 95% confident of that. It's a big range. Okay, so yeah, the margin of error is pretty big. Margin of error is almost 12%. That's a pretty big margin of error. So we might want bigger sample sizes to study this further, because the margin of error is quite large. 0.1152. Yeah, so on average, we think that the difference in whether you live or die in the ICU based on whether you have an infection or not is around 15% chance. So if you don't have an infection, you're 15% more likely to survive. Am I stating that right? That doesn't sound quite right. 15% more of people with infections die than people with no infections. That's better. But there's almost a 12% margin of error. Pretty big. However, if there is no difference, if it doesn't matter really if you have an infection, then that means the difference should be 0. Is 0 in this interval? Is a 0 proportion in this interval? The answer is no. 0 is over here somewhere, not in the interval. So our confidence interval states there is a difference. We're 95% sure that there is a difference in the proportion of people who die with an infection in ICU versus without an infection in ICU. So next we're going to run a hypothesis test to see what our p-value is like. We should get a relatively small p-value for this. With me? All right. So for the hypothesis test, we have to use the pooled parameter. All right. So with a hypothesis test, we start off with the assumption that there is no difference. If there's no difference, then you just add up all the people who died and divide by all the people that were in the ICU. And it doesn't matter whether they had an infection or not. So hypothesis test assumes there is no difference. And then we use that pooled proportion to calculate the standard error, not the individual proportions. But we still need those individual sample sizes. Those still matter. But there were a different number of people in each group. Okay, so I'm going to write a couple notes on this, and then I'm going to whip up a spreadsheet and see what happens. And we can try a stat key simulation for this also. All right, so hypothesis test. Difference in proportions. So here we have P1. And again, that is the proportion of ICU patients with infection who died. To proportion of ICU patients with no infection died. Null hypothesis is there is no difference. It doesn't matter whether you had an infection or not. The rate at which you die is going to be about the same. Now, based on the sample, it looked like you were almost twice as likely to die if you had an infection. See, that was in my spreadsheet. Let's see. if you had an infection, yeah, 28-ish versus 14, you're almost twice as likely to die if you had an infection. Shit. Okay. So I'm not going to go with that there is a difference. I'm going to say there's a positive difference, meaning you're more likely to die if you have an infection. So I'm going to say H alternative is that P1 is greater than P2, which is a higher rate of death given an infection. Higher death rates given you have an infection. I'm going to use the standard alpha, 5%. So you have two options at this point. You can either whip out your calculator, get that pooled statistic, get the standard error, and then use a normal distribution calculator to calculate the p-value, or you whip out the spreadsheet to do it. I'm going to use a combination of the spreadsheet and the normal distribution calculator to get a picture of it. All right, so do something. Whip out the spreadsheet, whip out a calculator. I'm going to pause for a couple minutes on the video, give you a chance to play before I do mine, but not done yet. All right, so from my calculator, I just typed in each proportion that we had from before. I looked at their difference, right? So the difference in dying is about 14.7% if you have an infection versus not. And then I got the pooled one where I just, take the people who died in the top, take all people in the bottom, and then I needed the pool to calculate the standard error. So this time the standard error, different than the confidence interval, is 0.057, blah, blah, blah. Okay. Once I have that, this piece of information right here and this one right here, so the difference in proportions and the standard error, I can just go over the stacking normal distribution and get a p-value. So I'm going to do that, then I'm going to go to the spreadsheet version, see if they line up. All right, so let me make a quick note. My standard error is 0.0573, should be enough decimal places. And my difference is 0.14778. 4 or 5 decimal places I'll go to. All right, so let's see, stack key normal, where'd you go? Here you are. Put you there. All right, so I want to reset. Then I need to edit. All right, what is the difference in means assumed to be according to the normal null hypothesis? 0, right? We're saying no difference. And then the standard error goes in where the standard deviation was. So mine was 0.573. Okay, enter. And then I'm doing a right tail test. So then I select right tail and I enter my sample statistic, which was the difference in the two of them, 0.147-ish, 778 maybe, that's right. And my p-value is 0.005. It's pretty small. Okay. So again, for a hypothesis test for a difference in means, you have to know what the difference in proportions, you have to know what the difference in proportions is. Then you're going to get the pooled proportion in order to get the standard error. Once you have that, you need a normal distribution calculator to calculate the p-value. All right. Spreadsheet should give us a similar result. So if I whip over the spreadsheet I shared out with y'all right here, I want to switch to a different tab. Let's see. Not that one, not that one. To proportion hypothesis test. All right, so that's a different example. Let's see, alpha, I'm going to go with 0.05. This was what, 24 people died out of 84 with an infection. And then 16 people died out of 116 without an infection. So P1 is like 28, 29%. P2 is 13, 14%. The difference is about 14%. Pooled is 0.2. So right, same thing my calculator was telling me. Standard error, same thing the calculator told me. This calculates a z-score, which I haven't talked about yet, but I probably should. What I really want is the right tail. 0.00496.005 to 4 decimal places, they match. Cool. Anyone else have success with this? Getting there? Easy to make a mistake. Usually takes me 2 tries to get it right, even with the spreadsheet. Now, I mentioned earlier, I like to use the spreadsheet because it has the formulas pre-typed in, whereas every time I have to type stuff into the calculator is a new place for me to make a mistake. And I make mistakes all the time. So if you do use a calculator, just double check you get the right numbers in the right spots. And same thing with the spreadsheet, double check you have the right numbers in the right spots. What else? How do you draw the picture without using stat key? So that's what I want to show you next. So I am going to highlight what I want here, pretty much that. And I'll show you how I'm going to draw a picture with this. Here, stop. So if you're just using the spreadsheet, oops, wrong button, try again. Now, then there is a way to use this information here to draw the picture. So here's how you would do it. Add to page, please. The spreadsheet calculates a z-score, and you can use the z-score to help figure out where the p-value should go. So reminder, we're doing a hypothesis test for difference in proportions, and we're assuming that P1 equals P2, which means 0 is in the middle. Okay. Next, based on the sample statistics here and here, and the standard error here, I calculate a z-score. What's a z-score? Well, a z-score for something like this is going to be whatever the sample statistic was. Well, that was P1 hat minus P2 hat, minus what the null says it should be, 0, divided by the standard error. So I just had the calculator give us that z-score. And if you think about z-scores in a normal distribution, a z-score of 1 is about there, 2 is about there, 3 is about there. Okay. Z equals 1, 2, 3. And my z-score was 2.6 roughly. So that means my z-score is about here, which means my p-value must be this tail out here. So that's where my z lies, which is about 2.6. So that gives me a hint on how to draw the picture looking at the z-score. Otherwise, just use stat key to help you draw the picture. My p-value is 0.005 roughly. And what's the decision based on this? Reject, reject, reject the null, right? It's a small p-value. The null said there was no difference. We're like, no, there's a significant difference. They're far enough apart. So our conclusion is what? What do we have evidence of? Yeah. We have evidence that people in the ICU die at a higher rate if they have an infection. Whatever the alternative hypothesis was, and that's what it was here. So we have significant evidence that the death rate is higher for people who have an infection. So that means you shouldn't go to the ICU if you have an infection. I guess it means if you have to go to the ICU and you have an infection, you're in pretty rough shape. There's like a ICU for an infection sounds like a plenty. Yeah. So good job. It's a lot of work. Congratulations on keeping up the good work.